In this video, we are going to review right triangle trigonometry that you did do in geometry with our SOHCAHTOA. Another option for that is writing it out this way. I kind of like that version because it shows it to you as the fractions. But the only catch here is we're going to now put things in different quadrants. So remember, we have quadrant 1, 2, 3, and 4 from our angle drawing earlier in the unit. In the first one, it's telling us the terminal side of our angle is in quadrant 1. So we're going to make the angle. Remember, the angle is made with the x-axis, so we're always going to draw a triangle attached to the x-axis, which is here. And theta is going to be the bottom angle attached at the origin. So cosine is 5 over 13. That is our adjacent over hypotenuse. And it helps sometimes even just label, like this is H, this is O, this is A. And we know this is 5 and this is 13. And you have to find the missing side. So we need the opposite side. So I'll do O squared. Actually, that kind of looks like a 0. Maybe we'll just call that X. X squared plus 5 squared equals 13 squared. And you will end up getting X is 12. So our opposite is 12. So for sine, we're doing opposite over hypotenuse, which will be 12 over 13. And for tangent, we are going to be doing opposite over adjacent, which will be 12 over 5. So anything in the first quadrant, everything will be positive. Now we're going to look at what happens when we move into our other quadrants. So here we're saying our angle is in between 90 and 180. So if we label our quadrantal angles, 0, 90, 180, that's as far as I need to go. It tells me I'm going to be drawing my triangle in quadrant 2. So draw a terminal side, attach it again to the x-axis, and we'll put our theta in here. Technically, theta is this bigger angle, but we're using the triangle to help us with solving in this right triangle format. So tangent is opposite over hypotenuse. So again, labeling, this is H, this is O, this is A. We'll put 5 here and 12 here. Now, because we're going to the left, this is going to be a negative 12. And if we were to look at this as a point, it would be like the point negative 12 comma 5, x comma y. So if you're struggling with figuring out which one is negative, left and down will be your negative values. And trying to list this out as a point up top here will help you kind of see that. All right, so now we have 2 of our pieces of information. We actually have the same triangle as up above, so our hypotenuse will be 13. Sine will be opposite over hypotenuse, which in this case is 5 over 13. And cosine is adjacent over hypotenuse, which will be negative 12 over 13. Okay, in our next example, we are going to look at radians to tell us about our quadrant. So this one says our quadrant will be, or theta value is going to be between pi and 3 pi over 2. So I'm going to list these out using radians. Pi over 2, pi, and 3 pi over 2. It's good to recognize the quadrantal angles in both formats. So this one is telling us we're going to be in quadrant 3. So draw the triangle's terminal side and then attach it to the x-axis with the theta inside. Sine is opposite over hypotenuse. So our opposite is here, hypotenuse is here, and adjacent is here. So we have 2 here. It's actually going to be a negative 2 because it's going down, and we have 3 on this side. I'm actually going to highlight the numbers in red so it's easier to see. And we need to find our missing side. I'll call it x for now, and then we'll change it over later. In fact, actually, we could just call this a. That will work out fine. So we're going to do a squared plus 2 squared is equal to 3 squared. Although I have a -2 in this triangle, the lengths are positive. So I never put negative information into this. So a squared plus 4 is equal to 9. We get a squared equals 5. Not a perfect square, but that's okay. So that means this side is going to be the square root of 5. It is also going in the negative direction because it's going left. So again, if we were to list this out as a point, we would write it as negative square root 5, because that's our x value, -2. And now we're going to do adjacent over hypotenuse, which in this case is negative square root 5 over 3. And then for tangent, we're doing opposite over adjacent. So this will be -2 over negative square root 5. Now that does simplify to be positive, because it's a negative over a negative, but it also has a radical in the denominator. So anytime we have radicals, we have the potential for rationalizing. If you recall, for rationalizing, we would multiply the numerator and denominator by the square root. And this will give us a final answer of 2 square root of 5 over 5. We'll see some rationalizing later on. That will be a popular thing because we will be working with a lot of radicals in the triangles. Our last example, we've been talking about when we set the triangles up, looking at it as a point to help us with the negative and positive. Now you're actually given a point. So -6, -8 would mean left and down. That puts us in the third quadrant. Sometimes that's a better way to write it than the Roman numeral, so you could write Q3 instead of the Roman numeral of 3. -6 is your x value, so that is going to the left. -8 is your y value going down. And then if we do 6 squared plus 8 squared is equal to our hypotenuse squared, we end up getting the 100 is equal to x squared, so we get a hypotenuse of 10. Now those numbers can be simplified, although they're not radicals, so when we put them in our answer format, we will simplify them. So we have adjacent, so here's our theta, opposite, and hypotenuse. So opposite over hypotenuse will be -8 over 10. That will simplify to -4 over 5. Cosine is adjacent over hypotenuse, so -6 over 10. That will also simplify to -3 over 5. And the last one, tangent, will be opposite over adjacent, -8 over -6. Simplifies to a positive 4/3 because you're doing a negative divided by a negative. So something to note too, when you have all three, 2 of them will be negative and then one of them will be positive in quadrants 2, 3, and 4. Quadrant 1, everything will always be positive.